In pursuit of answers to age-old questions like how far, what size, where in the universe, mathematicians come face to face with questions concerning change. Mathematicians have developed a unique language to help in their quest for solutions, a language called algebra. Consider this. You're a naval architect. You've been commissioned to design a sailboat. Not a leisurely cruiser, mind you, but a purebred racer. How can the language of algebra help make your boat a winner? In this module, we'll learn the following. Algebra is a language that describes quantities that change. A variable can be defined as a quantity that changes. And an input variable is often used to predict an output variable. Temperature changes. It's a common variable. Speed changes, as does the time it takes to cover a measured distance. So speed and time are both variables. Weight changes, sometimes depending on your distance from the Earth, which can also change. So weight and distance from the Earth are both variables. In the language of algebra, any quantity that changes can be considered a variable. Sometimes variables are related, and the value of one can be used to predict the value of another. For example, NASA scientists can predict the weight of an astronaut or of a spacecraft from its distance above the Earth. Distance is called the input variable, and weight is called the output variable. Project SETI uses radio waves to search for extraterrestrial intelligence. The time it takes a signal to reach its destination can be predicted from the distance the signal has to travel. So the input variable is distance, and the output variable is time. On the 4th of July, fireworks light up the skies high above the Washington Monument. The height of the fireworks can be predicted from the amount of propellant used. So the input variable is the amount of propellant, and the output variable is the height. Surgeons focus sound waves to shatter and remove kidney stones that cause pain to their patients. The amount of energy required can be predicted from the size of the stone. So the input variable is stone size, and the output variable is the amount of energy. Input and output variables are used every day in many different fields. In the world of racing sailboats, speed is an output variable that depends upon an input variable that may surprise you.
And here we go, nice wave. Slowly bringing this one down, guy back.
Speeding downwind in a stiff breeze is one of the thrills of sailing. With the help of honed crew, a skipper can wring every possible knot of speed from a boat.
Here's a little puff, bang gets ease, surf down the wave, bang back on. Beautiful.
But even the best skippers and crews can only make a boat go so fast. They face an ultimate speed limit. It's a linear relationship called hull speed.
Hull speed is the maximum speed a boat will go through the water, theoretically. And it's based on the length of the boat. The longer the boat, the faster it will go. And this is a linear function.
Creating a boat that can reach the theoretical maximum speed for its length is tricky business, however. Yacht designers like Johnstone must juggle many factors, such as weight, sail area, and hull shape in their effort to design a fast boat. Throughout the design process, Johnstone relies on algebra to help him predict the boat's chances of reaching its hull speed.
I'll start with a preliminary design and say, well, I think maybe I need this much sail area, I think I may need this much weight in the keel, etc. And then I'll plug that into my velocity prediction program, and I can come up fairly quickly with the parameters of this boat that I'm going to design that's going to be 45 feet long.
With the design finished, it's up to skilled craftsmen to transform the calculations into physical reality. Here, workers lay sheets of fiberglass in a precisely contoured hull mold. After it hardens, the hull is carefully broken free of the mold. The resulting shell is strong, light, and mirror smooth, qualities essential if the finished boat will reach its hull speed. The empty shell is filled with galleys, beds, an engine, and everything else needed to make life on board comfortable. Finally, the boat is ready for its maiden voyage.
You never really know until you put it in the water and try it out, no matter after all the mathematics and all the computer work and all the rest of it. You really have to go try it.
The first boat off the line proved that Johnstone's calculations were correct. It quickly and easily reached its hull speed of about 9 knots.
It felt sensational. As soon as we hoisted the sails, I mean, you could tell it was going to be a fast boat. When the 6 of us got off the boat, I think nobody had to say anything to anyone else. Everybody felt real good about the boat.
So what have you learned thus far? Algebra is a language that describes quantities that change. A variable can be defined as a quantity that changes. And an input variable is often used to predict an output variable.